This question is asked in GATE 2022 of electrical. This is from digital subjects and from counter topic. The question is a mod 2 and a mod 5 up counter when cascaded together results in a mod dash counter. Okay. So it's a very simple question. So you know the concepts, like if we have a mod x counters and if it is connected in series or in cascade with a mod y counter, okay, so equivalently this is equivalent to a mod xy counter. Okay, so wherever the counters of different mod numbers are in cascade, then the overall mod number is product of their individual mod numbers. So here it's a mod 2 counter and here it's a mod 5 counters. So overall it is equivalent to mod of 2 into 1 5, that is it's a mod 10 counters. Okay, so answer is 10. Nothing much to say about it. Very simple and low standard questions. Answer is mod 10 counter. This question is asked in GATE 22 of electrical. This is from digital subjects and related to the counter concept. The question is the maximum clock frequency in megahertz of a 4-stage ripple counter utilizing flip-flops, with each flip-flop having a propagation delay of 20 nanoseconds is dash. So this is a very standard formula based questions. In past also such kind of question has been asked. So in the ripple counters, okay, which is the asynchronous counter. So in that case, we have these relations t clock minimum, okay. This value should be greater than equals to n into TPD of flip-flop. What is n? N is the number of flip-flops we have. Assuming the delay are uniform or same delay of all flip-flop, which is the case in this particular question, this is what is the conditions to avoid any kind of errors. So t clock minimum means if you find the frequency, it will be maximum, because clock period is minimum means frequency will maximum. That means I can say if I'm reciprocating both sides, so what do you get? 1 by t clock minimum is less than equals to equal to change. This is 1 by n TPD of flip-flop. So this is basically f clock max, right, is less than equals to 1 by n TPD of flip-flop. So they're asking the maximum clock frequency. Maximum clock frequency means we should go with the equality cases. That means this is what is the condition. So maximum clock frequency means we can go up to equality conditions. So simply you can substitute this corresponding formula. N is given 4 stage means n is 4, and delay of flip-flop is 20 nanosecond. So this is 20 into 10 raised to power minus 9. So this much of hertz actually, right? So please simplify this. You will get, if you simplify this, so this answer is happening 12.5 into 10 power 6, which is equivalent to 12.5 megahertz, because it is asking the answer in the megahertz units. So if it is megahertz units, the answer is 12.5. So very basic and simple questions. The answer is 12.5. This question is asked in GATE 2022 of electrical. This is from measurement subject and related to error analysis and breeze concept. The question is, a balanced western breeze ABCD has following arm resistances like RAB, RBC, RD are given. RCD is unknown resistance. The value of RCD and its accuracy is. Okay, so let's first draw the corresponding breeze and then we can have the discussion. So let me take 4 nodes: A node, B node, C node and D node. So this is my node A, this is B, this is C, D. You can take on your own choice. So this is one resistance RAB, this is one resistance RBC, this is one resistance RAD, this is one resistance RCD. If I take the supply is this one, so definitely the breeze element, which is RBD, it should lie here. Okay, now let us write the data. RAB, so this is your RAB, its value is given this one, I am not writing it. Then this is your RBC, which is connected between B and C. RCD, so this is your RCD, this is your unknown, and RDA, so this is your RDA, and this is your RBD. But clearly it is given that it's a balanced piston breeze. Okay, the breeze is balanced. And in the balance conditions, you know the criteria. What happens in case of the balance? The product of this and this will be same as product of RBC and RDA. So in balance, okay, otherwise we can't have this, conditions. In balance, RCD multiplied by RAB is equals to RBC multiplied by RDA. That means what is your RCD? Because we need to find this RCD values. This is RBC multiplied by RDA divided by R of AB. So this is equals to RBC. So if I substitute RBC, it is 100 plus or minus 0.5%. Then RDA is 300 plus or minus 0.4%. And RAB is 1 kilo ohm. Okay, so 1 kilo ohm is 1000 ohms plus or minus 2%. Note carefully the units. So this is ohms, this is also ohms, but this is in kilo ohms. So that's what I'm writing thousands. So you know, in case of multiplication and divisions, so the percentage of errors are added up. Okay, so the true value, if I ask you, so true value will be 100 into 300 divided by 1000. Okay, so the corresponding true value 100 into 300 divided by 1000, and the error will be plus or minus sum of the individual error, that is 0.5 plus 0.4 plus it is 2.1, this much of percentage. So here it is actually 2.1. This is 2.1%. Okay. So if you simplify this, so 2020 cancel. So this is coming 300 by 10. 300 by 10 is 30 plus or minus. If you add all these, 0.5 plus 0.4 is 0.9. 0.9 plus 2.1 is 3%. Okay, 30 plus or minus 3%. But if you see the options, so the errors are not specified in the percentage form, that is in absolute form. So this is equivalent to 30 plus or minus 3% of 30. So 3% of 30. So you can simplify this. So this is 30 plus or minus 3 by 100 into 30. So this is basically 9 by 10. 9 by 10 is basically 0.9 ohms. So basically your RCD value is 30 plus or minus 0.9 ohm in the absolute form. So 30 plus or minus 0.9 ohm, if you check, this is given option B, and B is the right answer for this questions. So very straightforward and simple questions. Answer is option B in this case.